Well, let's hope we don't have any more technical problems. Gosh, I don't know. My technical problems seem to be getting worse. The closer I get to everybody's finals, I hope I can survive for 2 more days. So what are we doing tonight? Is this our last session before your final?
Yeah, it is.
So you must have some review material.
I do, but I've already finished it.
Wonderful. Wonderful. So what would you like to do today? What subjects are giving you the most difficulty, that you're most frightened of on the final?
Honestly, I'm not sure.
Do they let you use a cheat sheet? Do they give you a note card?
No, they don't.
So you have to memorize everything. Okay. Well, let me test you on your memory.
All right.
What's the vertex formula for a parabola?
Y equals a times x minus h plus k.
Squared plus k. Don't forget the square. What's the distance formula between 2 points?
The square root
Remember that the distance formula is basically the same as the hypotenuse of a right triangle. If you think about it, if I have a point there and a point there, it is the hypotenuse of that right triangle. So it's delta x squared plus delta y squared. And what does delta x mean?
x1 minus x2.
And what does delta y mean?
y1 minus y2.
That's the way I like to remember it, because it really is the change in the x squared minus the change in the y squared. And guess what? You can do these in any order you want. You could do x sub 2 minus x sub 1 if you want, because once you square it, it all becomes positive. How much conic sections did you get into?
Conic sections?
Yeah. Oops. Now says Cole White has left.
I'm still here.
I know, but we're on the phone. Oh, no, we're not on the phone. Huh. No, you're still logged in. What number did I just write?
8.
All right. Weird message that it sent me. All right. Let's hope we can get through this session. Did you get into ellipses?
No, I don't think so.
You get into circles?
No.
Or parabolas. So you have not done conic sections. You don't know what focus means, directorate.
Oh, those. Yes, we did those. We did those.
All right, let's talk about the general formula for a parabola. There are 4 conic sections. Parabola is one, circle is another, ellipse, you may not have gotten to ellipse or hyperbolas, but I'm pretty sure you got to parabolas and circles.
Yeah.
What is the general formula for a parabola when you're talking conic sections? In other words, it's actually slightly different than the vertex format. The vertex, hold on, let me close my door. The vertex format of a parabola is not that different, but it's a little different. Let me first of all, when you're talking conic sections, this is the standard format for a vertical parabola. Does this look familiar or not?
Mm-hmm. Yeah.
Because not everybody uses this. You'll notice that if I divide both sides by 4p, I would have y minus k equals 1 over 4p times x minus h squared. Then I could add k to both sides. Wow, that looks like the vertex format. Only a is equal to 1 over 4p. So it's really not any different. As long as you remember a equals 1 over 4p, then you could work from either vertex format or this format. The advantage of this format is that p is the focal length, or rather the distance from the vertex to the focus. So if I have a parabola and there's a focus right there, that's p. Okay? So if I gave you an equation of a parabola, where's the vertex of that parabola?
2, 3.
Remember, the x-coordinate always goes first.
Oh. So 3, 2.
Does it open up or down?
Should open up.
Remember, it doesn't matter whether the A is over here or the 4P is over there. If that thing's positive, it opens up. If A is positive, it opens up. Okay?
Mm-hmm.
So it's like that. Now, what's the distance to the focus? What's P?
P is 2.
Yeah. In other words, you set whatever the coefficient is equal to 4p, and that allows you to solve for p. And on the other side of that parabola, we have a directrix, which I unfortunately drew to be on the x-axis. I didn't want to do that, but that distance is also p. So when they ask you about the focus or the directrix of a parabola, that's what they're referring to. Okay? Now, let's just talk about horizontal parabolas, because this is the first time you've ever been exposed to these. Parabolas that look like that, right?
Mm-hmm.
What's the equation of that parabola? The general equation is different. When you have a horizontal parabola, it's not a function.
Is x equals y squared?
No, it just switched the x and h and the y and k. So that you have 4p times x minus h equals y minus k squared. Now,
Okay.
the basic difference is this is x equal y squared. Whereas your whole math career, it's always been y equal x squared, correct?
Mm-hmm.
Y equal x squared is an up and down parabola. It's either pointing up or it's pointing down. X equal y squared is a horizontal parabola. If everything's positive, it's pointing to the right. If there's a negative sign, say x equal negative y squared, that means it's pointing to the left. And still has focuses, so we still use this equation. But the difference is one is x equal y squared and the other is y equal x squared. Alright, let me think. What other subjects should we talk about in the next 15 minutes? You tell me. How's your trig?
My trig's fine.
I thought so. Okay. How's your, what other esoteric stuff did you touch upon this year? Combinations, permutations?
Rational functions.
What's that?
Rational functions.
Rational functions. That's what a rational function is. They tend to be hyperbolic in nature. If I said graph that, what would be your first job?
Finding the asymptotes.
Okay. What's the vertical asymptote? It's always the same. Vertical asymptotes are always where the denominator is 0.
No, x equals
1. Now, horizontal asymptotes are a little bit tougher. They're based on a number of things. In this particular problem, since the degree of x is the numerator is the same as the degree of x in the denominator, then what's the horizontal asymptote?
Y equals 1.
Okay. And once you get that grid on there, now you know that the thing is either going to graph like this, in other words, a typical hyperbola, but perhaps it'll be in the second and fourth quadrant. I've never particularly figured out a good way to figure out which one it is other than the following way. Plug a point in for x. Pick a point. Remember, this is 1, and that's 1. Pick a value for x.
0.
Okay? When x is 0, what's y?
Negative 1.
So when x is 0, right there, and y is negative 1, is it my black curve or my red curve that's the correct one?
Black curve.
Yeah. And that's the way I always tell. Because sometimes it's more complicated. And make it x minus 1 over x plus 1, and I think it's the second and fourth quadrant. But it's not easy to tell by just looking at that. I know if you had 1 plus x over 1 minus x, I believe that is the second and fourth quadrant. But yeah, because if x is 0, y is 1. And for y to be 1, it would have to be in that second and fourth quadrant. It's a little troublesome because 1 would still, oh no, minus 1 would be the horizontal asymptote. Notice that if I had that function right there, my horizontal asymptote wouldn't be at 1. The ratio of the coefficients is minus 1. So I still have a vertical asymptote at 1, but now my horizontal asymptote is there. So when I go to figure out whether it's the black or the red, and I plug 0 in. Whoops, meant to draw that asymptotic to my grid, not the x and y axis. So in this case, when I test a point, x equals 0, y equals 1. So it has to be my red curve, right? In other words, there's y equal 1. Whereas the black curve would be way down there, definitely below my horizontal asymptote. So in this case, I know it's the red curve, and I would erase the black curve. Now, they're not always first and third and second and fourth, but I got a feeling on this test you take, they're going to be first and third or second and fourth. In other words, I can think of a function that would be first and second, which would be y equals 1 over x squared. Hyperbolic, vertical, horizontal asymptotes, but this looks like this. In other words, if the bottom is squared relative to the top, then you could be in first and second quadrants. But I don't think they'll give you something like that. Any problem you're going to run into on your final tomorrow involving rational quotients is going to be first and third or second and fourth. I'd almost bet money on it. So just know that, and know that the way you begin those problems is by laying out your grid of horizontal and vertical asymptotes. That's the very first thing you want to do. What else, Cole? We got 10 minutes. Tell me something else you'd like to talk about for 10 minutes in the way of math.
Adding and subtracting polynomials. As far as like if it's saying like combine f of x with g of x, or subtract f of g of x from f of x, or f of g of x.
Right. First of all, adding and subtracting polynomials is really quite easy. There's no way you have a problem with this.
Yeah, no, that's
I have that polynomial, and I'm subtracting that polynomial. You just subtract like terms. 2x squared minus x squared is x squared. X minus a minus x plus 2x minus 10 minus 5 minus 15. So when you have f of x minus g of x, just subtract like terms. Same thing with f of x plus g of x. Same thing with f of x divided or multiplied by g of x. In other words, you know how to multiply 3 terms by 3 terms. Just do every term by every term. And the only one that might be reasonably difficult is f of x divided by g of x. And there you just use long division. In other words, if I give you, they're liable to say something like, what's x plus 5 divided into x squared minus 10x minus 6. Well, you know how to do long division with this? In other words, this is one polynomial divided by another one. What's the first step when you do this long division?
I don't know.
Divide x into x squared. Start there, always. That's the only piece you do in the first step.
Okay.
If it was x cubed, you'd divide x into x cubed. But you divide this into that, okay?
Okay.
Now, the next step is to multiply that by both terms. So I get x squared plus 5x. Just like long division, you subtract. Minus 10x minus 5x. Remember, I'm subtracting. Is minus 15x. Bring down the next term. Repeat. In other words, every step is exactly the same as the previous one. I'm going to divide x into that. I get minus 15. Then I'm going to multiply minus 15 by both terms to give me minus 15x minus 75. Now I have a remainder of 69. So my answer is x minus 15 plus 69 divided by x plus 5. That would be the answer if they asked you to divide those two polynomials.
Okay.
Now, one thing that's worth knowing, I believe you've covered this, is that for x plus 5 to be a factor of that polynomial, you have to get a remainder of 0. If you do not get a remainder of 0, it's not a factor, which means minus 5 is not a 0 of that. Okay? But if that is a linear factor of whatever size polynomial you have there, then when you divide it, you will get a 0 remainder. And that's when you can use synthetic division, because synthetic division gets to that remainder quicker than long division does. For one thing, synthetic division switches the subtraction process to an addition process, gets rid of all the variables which aren't necessary in the first place. So that's what synthetic division does. And you use synthetic division to see whether you get a remainder of 0. If you get a remainder of 0, that means what you've divided by synthetically is one of your zeros of that function. Something a little bit harder, which perhaps you were really talking about, is these kind of things.
Yeah.
Composite functions.
That's what I'm talking about.
All right. What is f of g of x?
X squared plus 6.
No, you don't have any problems with these. What's g of f of x? First of all, write it in a nicer manner. In other words, what are we taking g of?
X plus 5 over x minus 1.
I like to see that step. Because now we know how to do that. Because all you do is whatever's in the parentheses, you substitute for x in the g of function. So g of that is equal to what?
X plus 5 over x minus 1 quantity squared plus 1.
Yep. You know those good. You don't have any problems with those. So, composite functions. What's required for f of x and g of x to be inverses of one another? What test has to be true? In my previous problem, well, forget my previous problem. If I tell you that f of x equals something and g of x is the inverse of f of x, what has to be true about f of x and g of x? That has to be x, and this also has to be x. That is the true definition of inverses.
All right.
So if they give you two functions and they say prove one is an inverse of the other, you've really got two ways to do it. You can solve for the inverse. I know you know how to do that. And say, well, when I solve for the inverse, it equals this other thing, so therefore they're inverses. But they may have a way of making you do that test right there. In other words, they may want you to prove that f of g of x is equal to x. In other words, that would prove that you knew how to do f of g of x, the composite function. And it would also prove that you can do the algebra involved and get it down to x. So I can definitely imagine there's a problem on there that would require you to know this, both of these. Now generally, if you're proving that one function is the inverse of another, you only really have to prove one of them. I've never found an inverse function where f of g of x was equal to x, but g of f of x was not. So prove that, and you don't have to worry about that. But both of them have to be true. Cole?
Yep.
You got anything special planned for this summer? What are you doing?
Not really, just hanging out.
Just hanging around? What kind of math are you taking next year? Are you signed?
I wasn't able to get changed over to trig, so I'm going to be taking stats and AP stats.
Okay. Well, good luck to you. Enjoy your summer, and good luck on your final tomorrow, and perhaps we'll work together again, maybe not. I don't do stats or AP stats, particularly not AP stats. So good luck on that next year.
Will do. Thank you.
Okay. You're welcome.
I'll probably end up taking math in college, so.
That's true. I'm sure you will. You've got math skills. You should definitely go into something STEM related, would be my guess, or my recommendation. You got as many math skills as most any student I've got. Take advantage of that skill, because there's always demand for people that have math skills. Which means when you go to college, you'll be taking pre-calc, trig, calc, all of those I can help you with.
Okay.
All right? All right, Cole. Have a good one.
You too.
Bye-bye.